Okay. So in convection, there are two types. One is called forced convection, the other is called natural convection. In a forced convection, the flow is created externally by using a blower or something. You're creating an external flow, and there is the fluid that is convecting the heat. In natural convection, the temperature difference will create a density difference, and this density difference itself will create a flow. You know, temperature difference is what drives heat transfer. Here, the temperature difference creates heat transfer, as well as the temperature difference itself creates the flow. For example, if you put a vessel full of water on the stove, you see that convection currents are set up. Why are convection currents set up? Here the temperature is high, there the temperature is low. At the bottom, the water is touching the vessel, which is very hot, so the temperature is high. And at the top, water is in contact with the atmosphere, so initially the temperature is low. When you have high temperature, water has a low density. When the temperature is low, the density is high. So this is like a less dense fluid, and it's like a heavy fluid. So this is like a lighter fluid, and that is like a heavier fluid. You cannot have a lighter fluid below and a heavier fluid above, and this is called unstable stratification. Whenever you have heating from below, a liquid or a fluid, and you have heating from below, then the temperature below will be high, the temperature above will be low, the density below will be low, the density above will be high, and the lighter fluid is below and the heavier fluid is above. This is called an unstable stratification. For example, you cannot have oil. Imagine you are having oil below and water above. You cannot have this stable. Water will come below and oil will be displaced up. That's stable stratification. So whenever you have an unstable stratification, the lighter fluid will try to go up and the heavier fluid will try to come down. So you will see convection currents that is being set up. You would have done this experiment in school physics. Okay, just at home you can do. To visualize the flow, you can put some sawdust or something to see the convection current. You can put salts of potassium permanganate to see how the convection currents are set up. So in natural convection, the temperature difference itself creates a density difference, and because of the density difference, if there is an unstable stratification, there is a flow. Now if there is a fluid flow, fluid is also going to take heat. As the hot fluid goes up, it's going to carry heat, and the cold fluid is going to come down. So there's going to be mixing, there's going to be a heat transfer because of the fluid flow. And you know, heat transfer because of motion of the fluid is called convection. There has to be a fluid motion for it to be called as convection. If the fluid is stationary, it's going to be called as convection. If the motion is created by the temperature difference itself, then you call it as the natural convection. If the motion of the fluid or the fluid flow is created by external means, then you call it as forced convection. So in this chapter, you will have questions from both. Usually the first question is from forced convection. The optional question is from natural convection. We'll first try to understand forced convection. If time permits, we'll go to natural convection. Now if you come to forced convection, you have two types here. One is called an external flow and the other is called an internal flow. What is meant by an external flow? External flow is flow past solid objects. For example, you can have a flow past a flat plate. There is a flat plate. Maybe it is hot, say this is at a temperature of 100 degrees Celsius, and there is a flow past a flat plate. Say the flow is at 30 degrees Celsius. This is clear. So what will happen to the fluid? If a fluid is flowing past a hot plate, what will happen to the fluid? The fluid become hot because there is heat transferred from the plate to the fluid. There is a temperature difference. Because of the temperature difference, there is going to be a heat transfer. And here the fluid also washes the heat away. So this is a convection heat transfer. So what will happen is the fluid temperature keeps rising. Maybe the fluid is coming here at the end of the plate of some length L. The fluid temperature could come to, a mean temperature of the fluid could come to say 60 degrees Celsius. If it is long enough, it could be heated and the air could come at 60 degrees Celsius. So this is flow past a flat plate. This is external flow because the flow is happening outside the plate. This is called an external flow. Then you can have flow across cylinder. So you could have a cylinder like this. That is the front view of the cylinder. So the cylinder is going inside the plane of the board. And you could have a flow past the cylinder, not flow through the cylinder. There could be a cylinder and there can be flow past a cylinder. So this kind of situation you can have in the radiators and so on. Inside the radiator, it's an internal flow. You can have one fluid. Outside the radiator, you can have air or something forced so that the fluid within is going to get cooled. So this flow outside the cylinder is an external flow. So this is flow past a cylinder. Similarly, you can have a flow past a sphere. If you are cooling, for example, a spherical metal ball which is taken from a furnace, then you can have a draft, you can create a flow, and that would be flow past a sphere. If you have a light bulb, for example, you have a light bulb, you want to cool the light bulb, you can assume that the light bulb is a sphere. Then you force air over it, then it will be flow past a sphere. So you can approximate certain situations to be flow past spheres. So mainly in external flow, we will be studying flow past a flat plate, flow past a cylinder, and flow past spheres. In each cases, we are going to study about laminar flow and turbulent flow. First thing you will check is, in each of these cases, is the flow laminar or is the flow turbulent? How do you know whether it is laminar or turbulent? Reynolds number. So the Reynolds number will tell you whether the flow is laminar or turbulent. And the critical Reynolds number is going to be different for different situations. This will have a critical Reynolds number below which the flow is laminar. Above the critical Reynolds number, the flow is turbulent. This will have a different critical Reynolds number below which the flow is laminar, above which the flow is turbulent. So you have something called a critical Reynolds number. This is very important. This will be available in the data book. So whenever you solve external flow problems, first thing you will check is you will find the critical Reynolds number and you will check whether the flow is laminar or turbulent. If it is laminar, you have to use certain correlations. If it becomes turbulent, you have to use some other correlations. Okay, the next category of flow in forced convection is an internal flow. The word internal itself suggests that it is going to be flow through a pipe or flow through a duct. So the first case, you have a circular pipe and you have flow taking place through the circular pipe. What are the situations? You can have a radiator tube through which oil can be forced. Or you remember condensers in steam power plants. In a Rankine cycle, you have a steam condenser, that's also a heat exchanger. So inside a steam condenser, what happens? Steam is going to condense. There is cooling water outside. From the cooling tower, you have cold water circulating outside the tubes, and within the tubes, you have hot steam. You have steam through the tubes. And what happens when steam is cooled? Steam will condense. So that's an example of an internal flow. There are so many situations in which you will have an internal flow. Internal flow happens whenever there is fluid flowing through a circular duct and there is heat transfer. So here there is steam flowing through the duct, and because there is a temperature difference, there is going to be heat transfer from the steam to the water outside. So whenever there is a fluid flowing inside a tube and there is heat transfer taking place, you call it as internal flow. And internal flow, you can have flow through circular ducts, or you can have flow through ducts of other cross section. For example, you can have a duct of rectangular cross section and there can be flow taking place within the duct. In HVAC applications, you usually have rectangular ducts and flow taking place through the rectangular ducts. So if you have a non-circular duct, how do you calculate the heat transfer rate and the convection coefficient in these kind of situations? Again, it's a forced convection. You're creating the flow. It's not a natural convection. You have to create the flow externally. Again, what is important is you have to look at whether it is laminar or turbulent. How do you know that? You find the critical Reynolds number. If the Reynolds number in your situation is below the critical Reynolds number, the flow is laminar. If your Reynolds number is greater than the critical Reynolds number, then the flow becomes turbulent.